Hello, I'm Simon Whistler. You're watching the Today I Found Out YouTube channel, and in the video today we're looking at why helium changes the sound of your voice. The air in your lungs gets pushed up by the relaxation of your diaphragm. It then goes through your trachea and out of a small orifice that has two folds of skin, vocal cords on either side of it, in the shape of a V. This is called your larynx, or voice box. As the muscles that attach to your voice box tense and relax, they create a vibration of the cords. As these cords vibrate, they release pulses of air. The tension in these muscles creates the differences in frequency. The higher the tension, the higher the frequency, and therefore the higher the pitch. This frequency is measured in hertz, how many times a second this repeats. For example, nearly all human speech sounds usually range from approximately 200 Hz to 8,000 Hz, meaning the sound waves vibrate at approximately 200 to 8,000 times per second. Once out of the voice box, the air travels into the area of your mouth that can be informally known as your vocal tract. As you manipulate your tongue, jaws, and lips, you can change the resonant frequencies created by your vocal cords, allowing you to make the many different sounds of speech. Together, the sounds we hear created by the air flowing at different frequencies and resonances creates our voice. One other factor affecting pitch is the thickness of one's vocal cords. The thicker the folds of skin are, the deeper the voice. This is due to the amount of mass your cords have that the air has to manipulate. As you would expect, then, men tend to have much thicker folds of skin than women. So now let's talk about the air that's coming out of your lungs. The number of molecules in a fixed volume of gas, like the volume of air in your lungs, does not change with the type of gas, assuming the pressures are reasonably low. As long as the temperature and the pressure are the same, it does not matter whether it is helium or air. The number of molecules is always the same. The mass of those molecules is then measured by atomic weight. Atomic weight is a dimensionless physical quality, which is why it works so well for a gas that does not necessarily have a given dimension. It is the ratio of the average mass of atoms of an element compared to 1/12 of the mass of an atom of carbon-12. All that basically means is that the higher the number, the heavier the gas. Helium has an atomic weight of 4.002602. Air, which is approximately 80% nitrogen, has differing characteristics depending on the environment. For instance, if you live in Los Angeles, it's about 99.27% car exhaust. Because of this, its actual atomic weight is impossible to precisely define. However, it is generally about 7 times heavier than helium. So why the perceived difference in your voice with helium? The answer lies in how sound waves travel through a given gas. The more dense or heavier the gas, the slower the sound wave will travel. Helium is much lighter than air. The speed of a sound wave through helium will then be much higher, so by inhaling helium and using it as the source of the perceived sound, you are simply increasing the speed or frequency of your voice. You are not changing the pitch, since your vocal cords are vibrating at the same speed as when you are using air. You are also not changing the configuration of your vocal tract. So while the base frequency of chords remains the same, the frequency of the sound heard by others is increased due to the wave traveling through helium much faster than through air. So I really hope you enjoyed that video about helium changing your voice. If you did, please give us a like below, it really helps out, and leave us a comment to let us know what you think of this video, and don't forget to subscribe for other great videos just like this, and on the right there are a couple of other examples of other videos we put out, so be sure to check those out, and thank you for watching.